Lesson 4.1 is polynomial functions and models. A polynomial function is a function of the form f of x equals a number times x to a power plus another number times x to a different power plus so on and so forth all the way down, with all of your powers being natural numbers, which means that they are non-negative and they are not fractions or decimals. The degree of a polynomial is the highest power. When it's written in standard form, it's just whatever the highest power is. If it's in factored form, it's the sum of the powers. Your leading coefficient is the coefficient with the highest power of x. Your constant term is the term with no x. Turning points are how many times a polynomial changes directions, and a polynomial has at most one less than its degree turning point. So if it was a degree 5 polynomial, it can have at most 4 turning points. A power function is a monomial of the form f of x equals a times x to the n, where your n, again, is a natural number, so just those one terms. In behavior is how your function behaves as x gets very large in either the positive and the negative directions. Your real zeros are any real numbers r for which f of r equals 0, so your x-intercepts. And multiplicities are the power of a factor of a polynomial. In behavior of a polynomial is determined by its leading coefficient and its degree. So if your degree is even, your in behavior is going to end in the same direction. Think about an x squared graph. If your leading coefficient is positive, then they're both going to go up. Think about a positive x squared graph. So it's going to look like this. So as x goes to either positive or negative infinity, f of x is going to go to positive infinity. If your leading coefficient is negative, it's going to be reflected across the x-axis, so therefore as x goes to positive or negative infinity, f of x is going to go down towards negative infinity. If you have an odd degree, think about an x cubed graph. They're going to end in opposite directions. Odd goes with opposite. And if it's positive, think of a positive x cubed graph. So as x goes to positive infinity, y is going to go to positive infinity. As x goes to negative infinity, y is also going to go to negative infinity. If it's been reflected across the x-axis, your a value or your leading coefficient is negative, then as x goes to positive infinity, y is going to go to negative infinity, and as x goes to negative infinity, y is going to go to positive infinity. Multiplicity is the power of a factor. So if you have a factor x minus r to the m power, then m is your multiplicity. If m is odd, then your graph is going to cross the x-axis at that value. Think about, again, like an x cubed graph crossing the x-axis. And if m is even, it's going to touch and bounce back off. Think about like an x squared graph again. Here we have two different power functions, x to the 5th and x to the 4th, which have been transformed. So we're going to describe their transformations and then graph them using transformations. So for this first one, we have a reflection across the x-axis, and then it's been shifted right to. So I use my table here at -2, -1, 0, 1, 2, -32, -1, 0, 1, 32. And then I reflected everything across the x-axis by multiplying all the y coordinates by -1, and then I shifted it right to by adding 2 to all my x coordinates, and so I end up with 0, 32, 1, 1, 2, 0, 3, -1, and 4, -32. And it looks like this. So for this one, same thing. I have x to the 4th parent function, so -2, 16, -1, 1, 0, 0, 1, 1, and then 2, 16. And then I multiplied all my y coordinates by 2 for my vertical stretch by 2, and then I added 1 to shift it up 1. So I end up here. And then I also shifted it to the left 1. So I subtracted 1 from all of my x coordinates. And so I ended up with this, -3, 33, -2, +3, -1, 1, 0, 3, and then 1, 33. So this function f of x equals x squared minus 2, we want to find the following in order to be able to graph this thing. So first off, we have this already in factored form. That's always step number 1. If it's not factored, make sure you factor it completely. So when we want to read off the degree, because this is in factored form, we can add up the powers of the factors. So we have this x squared, and then there's an invisible 1 on this x minus 2. So this polynomial is going to be a 2 plus 1. It's going to be a degree 3. Because this is in factored form, we can read off our zeros pretty easily. So for our first one, what makes x squared be 0? That would be an x equals 0. And then what makes x minus 2 be 0? That would be an x equals 2. And then for the multiplicity is the power of that specific factor. So our multiplicity on x equals 0 is a multiplicity of 2. And then our multiplicity on x equals 2 is going to be a multiplicity of 1. So then I go back to the little table that we have before. So a multiplicity of 2 is even, which means that it will touch at x equals 0. And a multiplicity of 1 is odd, which means it's going to cross. So looking at end behavior, our degree is 3, which means we have an odd degree. And then our a value is our leading coefficient, and there's an invisible 1 in front. So that means that our a value is going to be greater than 0. It's not non-negative. So because our n is odd and our a value is positive, as x approaches positive infinity, our y coordinates are going to approach positive infinity. And as x approaches negative infinity, our y coordinates are also going to approach negative infinity. They are going to end opposite, and as you go positive in the x, you're going to end up. Y-intercept, I'm going to plug in 0 for x. So I end up with 0 squared times 0 minus 2, and so that whole thing is just going to be 0. Because I have an x-intercept of 0, I have to have a y-intercept of 0. So then I'm just going to graph all of that. So we're not looking for anything super fancy, just kind of meeting all of these aspects here. So I have my two zeros, x equals 0 and x equals 2. My end behavior, I know as x approaches positive infinity, my y's are going to approach positive infinity. And as x approaches negative infinity, my y's are also going to approach negative infinity. I also know that I need to touch at x equals 0. So I'm going to come up, I'm going to touch, bounce back off, and then I'm going to cross here at x equals 2. So same idea for this next one. I have f of x equals negative 2 times x plus 4 times x plus 1/2 squared. Again, it's already factored, so that first step is out of the way. So I'm just going to find all these pieces and then graph it. So again, my x plus 4 has an invisible 1 power, and then I have a power 2 on the x plus 1/2, so I end up with a degree 3. My zeros are going to be x equals negative 4, which has a multiplicity of 1. That means it's going to cross my x-axis. And then x equals negative 1/2 has a multiplicity of 2, so it's going to touch the x-axis. My degree is odd, and my a value in this case is negative 2, which means it is negative. So it's going to end opposite and end down in the positive direction. So that means as x approaches positive infinity, y is going to approach negative infinity. And as x approaches negative infinity, y is going to go up to positive infinity. For my y-intercept, I plugged in 0 for x, and I got negative 2. So you're going to start high, you're going to cross at x equals negative 4, touch the x-axis at x equals negative 1/2, cross the y-axis at negative 2, and then end down in the negative direction. So again, here's another one. F of x equals x minus 2, x plus 1 quantity squared, x minus 1/2 quantity cubed. So this one, I have an invisible power 1 on the x minus 2, plus 2 plus 3, so I end up with a degree 6 polynomial. And then my zeros, I have x equals 2, which is multiplicity 1, which means it's going to cross, x equals negative 1, which has a multiplicity of 2, which means it's going to touch, and x equals 1/2, which has a multiplicity of 3, which means it's also going to cross. I have an even degree and a positive a value, so as x goes to positive or negative infinity, y is going to go up towards positive infinity. It's going to end in the same direction and end up. And then for my y-intercept, I plugged in 0 for x, and I end up with a positive 1/4. So I plotted all my points here. Then cubed multiplicity here is just going to make it flatten out a little bit instead of just purely crossing, but it still crosses through there, and this is what it looks like. So here's the last one. We have f of x equals negative x to the 4th plus 2x cubed plus 8x squared. So on this one, it's not factored, which means our first step is to factor completely. So I factored out a negative x squared out of all these, and I was left with x squared minus 2x minus 8, which factors into x minus 4 times x plus 2. And then I read the degree off when it was in standard form here. It was 4, or 2 plus 1 plus 1. So my three zeros, I have x equals 0, which has a multiplicity of 2, which means it's going to touch. x equals 4, which has a multiplicity of 1, which means it's going to cross, and x equals -2, which has a multiplicity of 1, which means it's going to cross. Our degree is even, and our a value is negative this time, so as x goes to either positive or negative infinity, y will be going down towards negative infinity. N's the same, and n's down. Y-intercept, if I look here in standard form, there's no constant on the end, so my y-intercept is going to be 0, also because I have an x-intercept of 0. So then I plotted my points. I'm ending down. I'm going to cross at -2, touch at 0, and cross at +4. On this problem, we're going the opposite direction. So they give us our zeros, or they give us some information, and they want us to write our polynomial. So they do give us our zeros. We have a 0 of 0, which they tell us has a multiplicity of 1, and a 0 of -1 and +3, which both have multiplicities of 2. And then they also tell us that it contains the point 1, -48. So I'm going to start this in factored form, knowing if I have these zeros, what that will mean, and then utilize the point after that. So utilizing those zeros, they tell us that we have a 0 of 0 with a multiplicity of 1, which means just an x. Then they tell us we have a multiplicity of -1 with a 0 of -1 with a multiplicity of 2, so x plus 1 squared, and then a 0 of 3 with a multiplicity of 2, so x minus 3 quantity squared. And then I put an a in front to represent our leading coefficient. So now I'm going to utilize the point 1, -48. So it tells us that it contains that point, which means it's on the graph. If a point is on the graph, it has to make the equation true. So I'm going to plug those values in for x and y and use that to solve for a. So I plugged in 1 for x in all of my x's, and I plugged in -48 for y. You get down, you get 16a equals -48, so therefore a would be -3. So our polynomial that fulfills these requirements is -3x times x plus 1 quantity squared times x minus 3 quantity squared. Here we have some data that represents the number of cavaliers produced per hour versus the cost of producing those cavaliers. And the first thing it wants us to do is draw a scatter plot of the two variables and then find some information from there. So I just used Desmos to draw a little scatter plot. This is the cavaliers per hour versus the cost. And we can see it's neither linear nor really quadratic. It's looking kind of cubic. It kind of turns around here. So the next thing they want us to do is to find a couple average rate of changes. For B, they want us to find the average rate of change of cost from 4 to 5 cavaliers. So average rate of change is slope, so I just found the slope between 443 and 550, and I got 7, and then because it's in thousands of dollars, $7,000 per car. So it costs $7,000 more per car to increase from 4 to 5 cars. And then from 8 to 9, I did the same thing, and I ended up with $20,000 per car. So we can definitely see it's not linear because those average rate of changes are not the same. Now they want us to use a graphing utility, and they specify a cubic function of best fit. So I'm going to go ahead and do that and then graph that on our scatter diagram. So I used a graphing calculator to create a cubic regression. I got c of x equals 0.215x cubed minus 2.347x squared plus 14.327x plus 10.223. And then I added that curve to my scatter plot. It's almost perfect. So then it says use the function in part D to predict the cost of manufacturing 11 cavaliers. So I plugged in 11 and I got 170.787, which is $170,787. And then part G says interpret the y-intercept. So I plugged in 0 for x and I got 10,223, which is just what's this in here, dollars, which basically if no cars are created or made, it still costs over $10,000 just to run the plant. And this has been the lesson for 4.1, Polynomial Functions and Models.